I'm Fabian Baier. I'm the founder and CEO of Pulze.ai. We're building a dynamic large language model automation platform. And today, I want to talk with you about basically model lock-in. I think a lot of you probably heard about vendor lock-in. I really think that current wave of AI is really like the sort of like the next big thing when it comes to like what was the last big thing, and that was, I think, cloud computing. And so when you went and, for instance, build an application and you build it on top of AWS or so, you got stuck with AWS, for instance. And so that's a typical example, I think, for what really like a vendor lock-in is. But now with the new wave, with these large language models that come out and multimodal models and so forth, like once you start building with one of them, you're stuck. Basically, your application is so specialized for this one specific model. You get to know its flavors, and you get to know the names, how to interact with it, such as that switching becomes more and more expensive as you proceed. And that's, I think, the number one problem that I think we identified, and the first one that we wanted to tackle. So, without further ado, there's this Cambrian explosion of models. I mean, it started very, very early, and then this paper came out. Attention is all you need, basically, for this. And then this like myriad of like models came into fruition into the world. And then you can compare this a little bit with how that was in the 90s and so forth. Like there's suddenly like a homepage, and everyone had homepages, and so suddenly there's the internet, and so everyone wanted to go on the homepage. And now, where do I find the right homepage? Oh, there's like Hasta La Vista, or like Yahoo and Google help you finding the right homepages for your specific use case, retrieving the right information for you. And the same thing is happening, I think, also like more maybe in the enterprise, but like in general, like for large language models, which is the most suitable large language model for me for that specific prompt. And I really think that there will be a future where there will be millions of these models. I really think there will be a few foundational ones, but really where the magic happens is with with a lot small, simple models, the open source models that can run more also on the edge, models that are able to basically like be domain experts in specific fields. And how do you know that you should go and talk to model A versus model B depending on the prompt, or how do you switch as a conversation and the context sort of moves on? And that's basically where we're really trying to help you with when you build a large language model application. So you're not locked in with one vendor, with one OpenAI, with one Anthropic of the world, but actually you're flexible and you can change and hop between these models, even dynamically. That's where the dynamic part comes in, such as that you always, when there's a new model comes out, you don't have that FOMO, oh my God, is my application suddenly bad? Well, there are actually things of like, how do I know that that response was bad? How do I know that the application that I have is currently like with that model worse off than with the other model? And so there's a lot of work that goes into scoring, benchmarking, evaluating these things, and that's where we started building our dynamic routing layer. So you can think about this dynamic routing layer as a way that helps you to navigate through that jungle of large language models that are out there to find the most suited, appropriate one for you. And so when you build these, like not large language models, but applications on top of that, what really happens is that first you get to know the style of the model. You, for instance, when you talk to GPT-4, it expects a specific sort of voice and syntax, if you will. It's like a little accent, like I have. And then maybe you talk to Anthropic, and Claude Instant V1 expects a different sort of way of addressing it to get the maximum out of it. And that's this whole like field of prompt engineering, and why prompt engineering is a thing. So you have like a specialized expert that knows how to do that. Like back in the days, maybe you know someone that is good with PHP, yeah, or someone is good with HTML. Those were like very advanced things back in the days, right? So the same thing happens here. Someone's really good with GPT-4, all right, great, they can get the most out of it. Because what I really want to do is I want to figure out the intent. I want to really know like what's behind that question, such as did I get the optimal answer, and like bridging really that gap on like articulating that. So everyone who's like using a large language model needs to be just very good in articulating. I'm also not really good in articulating, so like I really use these things to help me get my message across. And that's what like really like drives also this model lock-in, because you specialize on a specific model because you learned how to articulate for that one. And then there are other things with it. It's very expensive. So once you build an application on top of a model and you start like making your requests and you get through sort of like the first wall, and then you have a few more of these requests, it becomes very fast expensive. And then I think I always use that example on, like, for instance, if you asked GPT-4 what color is the sky, you get a very expensive answer for that, probably very accurate in that moment, but like, do you really want that in that moment? Can you maybe ask Ada or Curry, or can you maybe ask like a Goose AI to answer you that? And that makes it way cheaper. The other way is like when you think about writing code, do I need to use GPT-4 to produce some high-end Python output, or can I use Code Llama for this, or a fine-tuned version of Llama 2 that is specifically for my application on a fraction of the cost, 1/300th of the cost, or something like this. And I think that's also where the future really goes, where through fine-tuning and RAG pipelines, you can actually build like you squeeze way more of quality out of these smaller, cheaper models, such as they are very like highly qualified for like, your specific task. You don't have to go through that like very generalized foundational model that then gives you a very expensive answer that is maybe not even tailored to your use case. And then the third part here with the black box is really like the transparency of the model. What was the data that went in there? How was the data being used to like that it comes up with that answer? And was that an open source data set? Was that a data set that was from whatever places retrieved? And different parts of the world think different about different problems. And so is that answer really the most accurate one for me? It's really just like, how do I judge that that is a good answer? I don't even know where the inputs for this, the training for this, but like I just see the output. And so it is sort of unpredictable. Do I really want to have that in my chatbot? That it suddenly goes rogue? These sort of things. So there needs to be some guardrails, some control mechanisms, like in the post processing of this, to make sure that I can use that large language model. And then the other thing is the ongoing maintenance and upkeep. Think about it as like, I mean, like running these models you are expensive. There's this rush to a lot of silicon right now, and as they get smaller, you can run them probably on your laptop at some point as well. When M3 comes out, you can probably run like an entire like a little like autonomous driving car on your little laptop there. But the real thing is like it's a lot to keep up with all of this. The FOMO part is as well something. There comes a new model out. How do you know that this is maybe better and worth switching? And also like interesting things are like changes in its behavior. Let's say some of the models that are trained, that are like behind basically closed doors, they change their revision, their version. There's something like LLM drift, model drift, where the data through various pipelines, you see that also with ChatGPT, not as a model, but like basically as one way of interacting with these, that it can change, varies on the data when it was trained. So like detecting these things, maintaining it, making fast decisions to switch to that, all of that makes it really, really hard building these applications reliable in a way. And I think there's common consent that like what really is under the hood of a GPT-4 API call is like a few expert models. Each of them are 220 billions or so in parameters, and they really like are aggregated through some sort of like routing mechanism that then like finds that right expert model for this. And that's what our platform is actually doing. We're building this meta model that does that not just for like the closed source ones, but does that with all of the open source ones, with your own fine-tuned one and so forth, to have like not just like 8 or 12 of these expert models, but have potentially like in the millions of these expert models. And so the real question there is like, how can you come up with this sort of dynamic routing layer that like knows and is also efficient when it's about like going through not just like 8 or 12, but actually a higher number of these. And so the answer to I think avoiding all of these issues, the aforementioned issues, I think is really just like being flexible by being able to switch from these models, by trusting really in that sort of like decision engine, that matchmaking engine that knows when the prompt comes in, like which model is really at that moment in time the right model. And that could be that there's maybe a rush hour happening right now. OpenAI is down, the latency is really high. If you look at open source models, Llama 2 is hosted by a lot of the providers. So which provider should I choose? If Replicate is down, should I go over to, for instance, like Anyscale, or should I use a bunch of the other ones? And so all of this comes into play when you really want to make sure you build your large language model application. And so we went out, and that's on our blog post, blog.pulze.ai, we basically asked ChatGPT, come up with like 20 categories that are most representative for all of the requests that can come through a prompt. And those 20 categories, like arts and craft and like data science or entertainment and fun, we had it generate on the fly as well a bunch of prompts. And then we used these prompts to train a classifier on top of like a PyTorch to then go out and do some replaying with these prompts, and then go and have GPT-4 judge how good these answers were. And it's very surprising to see like how from let's say like 30 or so or 15 of the models that were at that time integrated at our platform, how different the performance is. So on the left, what you should see is that the scores that are red, they are bad, and the ones that are green, that are good. So when you look at, for instance, Goose AI, with most of these like answers, they were not really well like scored by GPT-4. And so we know that like when a lot of the questions that we should like send, we shouldn't send them to Goose AI, at least at that moment in time, because the answers were not really good. There's of course, we had other talks today where this was about bias and reduced bias. That you have, of course, bias that GPT-4 is always like rating its own answers and responses better than like from other providers and so forth. But the interesting thing is that there's a difference for these models, and we also see how these models become better over time, which is on the right. Most recently, when we ran this, we saw that like Anthropic notably increased its performance, if you will, its quality, its reasoning. AI 21 Labs had like very mixed performance, or Aleph Alpha had very mixed performance, and so we just keep track on that, and that is basically like one of the things that are represented in our internal knowledge graph that we built to find out which model is the right model for you to basically get the request. And so I want to walk you a little bit through that knowledge graph that we're building, and it all starts basically with this user prompt, and then we have at the moment our intention-tuned embedding model. What it does, it's basically contrastical trained, which means like we have a lot of good prompts and we have a lot of bad prompts, and with that the embedding model learns what is your intention behind this, like is that cluster of questions like answering this specific problem very well or bad. And so every prompt that gets through our platform within, by the way, overhead of just like 15 milliseconds or so, gets like embedded and compared to our knowledge graph to figure then out which model is in that specific category the best one for you. And that category is a dynamic one, it's a growing one, because we're doing this in a vector space. We're not doing this anymore hard-coded like we did like three months ago when we started out, but we actually further developed this into having this represented through vectors and doing that semantically. And so when these embeddings come back, and again, you can argue that there's maybe a model lock-in with that embedding model. But what we do is we basically like going and normalizing these data. So as we grow, we can like make these embedding models better, and we can go and have specific embedding models for specific things, not just like the intention, for instance, but also the task or specific domain experts, or like even your own scoring functions that are like embedding that model specifically or that prompt specifically for your use case. And we had today already a few talks about like how this lookup looks then in a vector database, and the vector database that we're using under the hood is also open source. It's Milvus, and then from there basically retrieve some sort of feature or a score, and with that we can start weighing it for that specific request. What's preference? What's most important for you? What is currently like, for instance, at present with this prompt, an attribute that is super interesting. For instance, was the distance here to our in our vector base something that is super important? Should it like be within a specific sort of range of that distance? But also other things like features and labels that are added to these prompts that we have. And so that is something that we can grow, and over time that makes that quality of our like sort of matchmaking, if you will, with the prompt way better, such as that we can aggregate that at the very end into something that is sort of like more like a binary and very easy to read decision. Because there's like, if you think about Mistral 7B or Kana, for instance, if you look at benchmarks there, all of these benchmarks there are like 5-6 benchmarks, and you need to look at them and you need to see like which one is the most relevant for me, and then you need to compare it. And so like I think simplifying this, making this like for people that want to really build applications on top of that, they don't want to like go into that entire rabbit hole. Making that super simple is, I think, one way of enabling and also democratizing the use of the most appropriate model. And then from there, once you have your score, you can also say like, hey, this is great, but maybe I want to have the cheapest one. What's the next best model maybe? Or maybe that request fails. What would be the next best model for that one? So there's some reliability, exponential backoff, caching, and so forth included. And then after this, we basically give you an answer. And we really, what this answer is, this is an answer that is like growing with you. So like very interestingly, for instance, when you integrate with Llama Index, what happens under the hood is these sort of extractions of features of your documents that you provided, and that task is a specialized task to summarize that, to extract the right feature, to figure out which are sort of like the tokens that I should use to then formulate the final prompt that is then sent to maybe a GPT-4 or something like this. And so these requests, we noted that like you saw that earlier in our graph as well, that Anthropic Claude Instant V1 is actually very good when it comes to these instructions, working well with Llama Index. And so like choosing that versus like always GPT-4 provides also like some protection against this model lock-in. So we know that like when you do building when you are building RAG pipelines, that under the hood you basically go and have this sort of like optimization going on. And so there I have a little representation on how that, let's see if I click on this, yep. On how our sort of like vector space looks like. Think about every color is sort of like a cluster. It could be like what is the favorite color of the Kardashians or so, or what is a good, what is 1 + 1. These are all different representations in the vector space. And so we take all of these clustered and replaying them to all of the models that we have in our platform. And this is costly, of course, but we're doing this for all of the users, so that's sort of like, that's basically how it gets cheap again for everyone. And from there we know, okay, this is a good model for math problems, this is a good model for other problems. All right. And so lastly, also about benchmarking. So there's these like prompts that come where we know the answers already. These are like sort of answer-based benchmarking. Helm is a very good one, or Luther's Harness is a very great framework, where we can very easily just say like, okay, here's this prompt, we know this should be the answer. If I send it to, I don't know, like let's say like Mosaic ML, and what the response is that really the right response? Is that the response that I want? So that's very easy to sort of like score and figure out, and you can score it for multiple things, how much bias is in there, how concise are the answers, and these sort of things. And then there are also more like open tournament ones, and those are the more interesting ones actually. Like think about like a little like a sports play where you have like two competing teams with each other and the better one wins. And so let's say you have a relative score. Suddenly there are two models that perform very well, both of them have maybe a score of 10. Now you can compare them in sort of like a ELO ranking pairwise, where you go and have this little LLM tournament going on to figure out for these open-ended questions where you don't have the answers, which of these are the better ones. And so we can build, and that's what we actually do, we build these scoring models, these large language models that are really good in answering for specific subcategories these questions. And here's a quick demo on at the moment what you can do on our platform. So you can go on top of our platform. You basically create an application that is backwards compatible with OpenAI, LangChain, Llama Index, and so forth, with all of these SDKs. So everything that integrates with OpenAI, Anthropic, and Replicate and so forth can be used by us. We standardize the response, so you get automatically logging. We are having Grafana and Prometheus and Loki metrics, so you can build your own alerts if someone is burning through tokens and so forth, so make it really enterprise ready. You can target these models, you can directly connect a specific model, and then like integrate basically into your application with just like 2 lines of code that change. Yep. I think also here at time, but like we have a Slack community where I invite you to join, where we get user requests, we get a lot of questions, super active, so really happy there. And then we also give everyone like $1,000 in credits on our platform if you build an application that you basically like don't have to go directly to OpenAI, don't have to go directly to Claude 2, but we want to protect you from that model lock-in. Just use us so you can basically hop between these as it makes fit. All right. Thank you.